All right, so here in this video, we'll be looking at the concepts of bone development and bone homeostasis. And with this, we'll mainly be looking at the concept of ossification. Ossification simply is the formation of new bone tissue. In embryonic development, this leads to the development of the skeleton, the future skeleton, this process of ossification. But even after you're born, your bones continue to grow, and so this ossification process continues on into early adulthood for some. And after that, even as adults, the bones can still change, but we don't call it ossification anymore. That process is called remodeling, which we'll look at in a moment. For the formation of the bony skeleton, this begins around week 8, and at week 8 of embryonic development, the skeleton consists mostly of fibrous connective tissue and hyaline cartilage, which, if you remember, we talked about hyaline cartilage in an earlier video. Bone tissue begins after this time, after week 8, and eventually replaces most of the existing cartilage in the body. There are two kinds of ossification. There's endochondral ossification, which you see here, endochondral. It means inside the cartilage is what that word means. Bone develops by replacing hyaline cartilage. The resulting bone then is called endochondral bone, which is what you see this picture of here. Most of our bones are endochondral bones. The other bones, or the other type of ossification, is called intramembranous ossification, and this develops from the fibrous connective tissues that are found in our embryos. And later, this type of bone is called membranous bone or intramembranous bone. And you can see here, we don't have a lot of this. It's found mostly in our skull and in our clavicles. And the purpose of this happening slowly throughout our life is it gives those bone tissues the ability to grow quickly. And this can happen through mitosis. Our bone tissue now can't grow through mitosis because it's all this really hard calcified type tissue. And so those cells have to grow really slowly. Whereas early on in development, they can grow really quickly through just a simple process of cell division. So we're going to look at these two types of ossification a little more closely. First, let's look at endochondral ossification. So all the bones, again, below the base of the skull are endochondral, except for the clavicles, and then the skull itself, except for a few of the inner bones of the skull, are also endochondral. These bones are more complex than intramembranous ossification, or this type of ossification is more complex because the hyaline cartilage that is there has to be broken down and replaced. It doesn't kind of just turn into it. It has to be slowly broken down by these steps. And so we're going to look at these steps here. There's 5 of them. You can see them across the bottom of the screen. And so the first step is that this bone collar forms around the diaphysis. This is a cross section of the bone, obviously. And so if you can imagine this being a 3-dimensional structure, this kind of collar develops around the outside of the cartilage, first step. And the second step then is that calcification also begins in the center of the diaphysis, and the cavity that is there, that cavity that's found on the long bones, you see it really, really clearly here, also begins to form at this time. In the third step, it's this periosteal bud. You don't really need to know that. You can just think of it, you know what the periosteum is. Periosteum is that outer covering. So imagine that periosteum invading the interior of the bone, kind of like enveloping it. And so that's when the outside kind of becomes like the inside, or the inside becomes like the outside. And so what happens is the spongy bone begins to form, and you can see here the blood vessels and such begin to go into the bone, providing it more nourishment. And so this is an important step in bone production because this is going to allow it to get nourishment, allow it to grow more. And then the next phase, then you're going to just see the elongation of that cavity and the bone growing more and more. And you can see there's more bone and less cartilage here. And then the last step then is when the epiphysis is going to ossify toward the end, and you still have remaining here those epiphyseal plates, which is where growth is primarily going to take place. Next, you have intramembranous ossification. Intramembranous ossification forms from the cranial bones of the skull and the clavicles. And so this ossification, this type of ossification begins at around 8 weeks, and it has 4 steps. So remember, it's different. There's not that cartilage there. And so here you have mesenchymal cells. Remember mesenchymal cells? They're the kind of like the stem cells for the cartilage. The mesenchymal cells are going to start differentiating, turning into osteoblasts. And osteoblasts are what going to begin making new bone tissue. So over here, or down here, sorry, that osteoblast is going to make something called the osteoid. And the osteoid is like bone-like tissue. It's like this hard stuff. But it ends up trapping these osteoblasts in here, and the osteoblasts then mature into full-on osteocytes or full-on bone cells. And so you start to have this matrix kind of form like we're familiar with when it comes to bones. This is going to slowly form the spongy bone and the periosteum, the outside section of the bone. And then lastly, that compact bone is going to form just deep to the periosteum, and inside that spongy bone, the red marrow is going to form. And so you don't have the epiphysis and the diaphysis here, so it just kind of forms from the inside out. And this is with intramembranous bone. And so let's look at bone remodeling. Every year, about 5 to 10% of our skeleton is replaced. And this has to do with this concept of bone remodeling. It's adding and removing bone in response to hormones. It could be in response to stress on the bones. If you put a lot of stress on your bones from, like say you lift weights, so you put a lot of stress on your bones, well, those bones are going to act to compensate. They are going to grow in order to compensate for that new mechanical force that's being put on it. If you gain weight, you have a new force acting in your body. Gravity is acting on your body more. And so the bones are going to remodel in order to make your skeleton strong to support your body. Calcium homeostasis is also maintained on a negative feedback loop. And so that calcium homeostasis also involves the remodeling of your bones. And so if your body needs more calcium, it's going to take the calcium from the bones. If it needs to put more calcium there, it's going to put it more on. And so you have this constant kind of exchange happening. And so your skeleton is constantly being made new. Every 10 years or so, your entire skeleton is new. And then lastly, let's look at some imbalances that can occur. Low calcium levels in the blood can lead to bone loss. This is called osteoporosis. It's a lot more complicated than that, but we'll just keep it simple. And too much calcium can lead to something like kidney stones. Again, more complicated than that, but you get the idea. Kidney stones are just a picture of what can happen with too much calcium. This can actually happen in other organs of the body as well through this too much calcium. The body has to put it somewhere, and it ends up building up in places like the kidneys. A disease called osteomalacia, or in adults, but rickets in children, is where the bones don't harden properly, and then they're unable to bear weight. This causes legs to bow like this, and this is not as common anymore. One of the reasons this isn't as common is because of something called vitamin D milk. Cows don't put the vitamin D in there. We do. And the reason we started putting vitamin D in milk is because there were vitamin D deficiencies, which led to things like rickets in children. And so the government decided to start putting vitamin D in milk, and this eliminated problems like rickets, and because vitamin D is formed through exposure to sunlight. And so they were just finding that less and less children were exposed, and so they had to put vitamin D in milk. This is almost eradicated completely in our own country, but it still can be a problem. And so vitamin D milk is something that was probably around to stay.